Hi, my name is Maciej Matyka and I will be talking about computational modeling with single prompts. The talk I'm now giving is a practice before the conference that is going to happen tomorrow. So at LBM in Prague there will be a live event where I will be giving this for the audience specifically from there. And also the reason is that I want to present to the visitors and people visiting my YouTube channel and students, and I think it's a nice topic because it's a very new related to AI and large language models. Yeah, so let's go on. And so what we see here on the plots are the fluid flow simulations over a car where the lattice Boltzmann method is used. And the reason I'm showing that is that that's an example of the code that I was developing when I was working on the fluid simulations for some projects. And it was written in C++. We are now also working on the fluid flows like that. This is three-dimensional, done with some external software, also wrote in C++. But the reason I'm giving this talk is that why I'm here. That's maybe the first question. So I have a lot of experience with programming. I was starting with assembler, C, C++, Python, also JavaScript. I'm teaching programming. I wrote a book about computer simulations with a lot of programs written for that and also C++ combinations. Is also a book about programming. And the reason I'm saying that is not to show off. I mean, this is my work. The thing is that I'm practitioner. I'm really practicing programming since years. And what happened now is, tadam, 2025. And this specific year was chosen by me because DeepSeek has appeared. And also right after that, Claude GPT introduced deep thinking, and so-called vibe coding started to be available to everyone. Now, a year ago, I gave a talk about it in LBM in Krakow, the previous conference that I'm going to attend tomorrow, and it was about prompting. So I was a bit new to the topic, as everyone now is, but I started to investigate it further. I spent almost 6, 7 months on working on the methodology, and today I have some results. So yeah, let's start with something simple. Let's play with something in 2026. So this was a small project I did like a week ago, just before the conference. We take a single prompt, we expect one result, and we want the result to be independent of the language model. So for instance, let's try something like this. Write a program in C++ that displays a red heart in the console. So it's pretty simple, yes, everyone could do that, just a bunch of couts and so on. When you, okay, the original prompts were in Polish, but it does not matter, you can try it in English, it will be the same. So the GPT 5.2, when you ask this chat to do that, will produce something like that. Of course, you may encounter different result. That's of course possible because of some temperature of the model. But anyway, so this is the result I got. And pretty funny is that it is a right heart shape. As you can see, the program is pretty well written, but it is not very like precise. Something is wrong on the top of the heart. Yeah, this is probably because of some rendering of the ASCII in the console. But anyway, GPT, I would say failed a bit. Yes. Now, when you ask different language models, you will notice that GPT 5.2 is okayish, but the worst one at this point, maybe we could say that Gemini is giving a nice help with some creative sentence. This is a hard help for you. DeepSeek does the same, also puts some sentence, does a very nice help, and Claude gives also a help. The thing is that the hearts are not the same. And what we would like to expect is that if we write a prompt like this, we don't need to shape it further, that we could get the herf that is the same everywhere. For that, we can use equations. So for instance, there is an equation you can take from the internet. It's an implicit equation for the heart shape. There are plenty of them in the internet, for instance, from Mathematica. And yeah, we take random one. So when we write down another prompt like this, write a program in C++ that displays a red curve with a resolution of 20 by 20 in the console, generated from the formula, and there is the formula from the previous slide, then we get this result. It's amazing. Gemini is giving still the same right answer. GPT failed terribly, putting even some strange ANSI maybe characters that my console cannot print. DeepSeek is giving a shape with a hole inside, and Claude is failing similar to GPT. That's pretty much very bad, because we really wanted to make the prompt more specific, and here only one gave a right answer. Let's go on. Now we write a program which specifies more. Write the program, blah blah blah, and then take care of the parameters and scaling so that the function actually generates the curve as it should. Use the star character for drawing. So we want to limit the problems of the previous prompt. And when we produce the code and run it like this, then we get a pretty nice curve with GPT, still the same Gemini 3 curve that we got previously. DeepSeek is still giving something with a hole, and Claude is giving curve, but it's cut. I don't know why. So it failed with the vision. I don't know. Then we write another one where we write design the curve so that its shapes fits in the console to solve the problem of Claude. Does not exceed the above mentioned field so that it is like field in the console, and make sure that the shape we get is a curve with one convex vertex at the bottom, this is for DeepSeek, and two concave vertices on the top with two roundings. Okay, pretty much this is what we want. I think if we asked some programmers to write it, they would probably give more or less the same shape. And this is what happens, for instance, with Claude. It's interesting. Okay, this is the Polish prompt that I was using in original, but what is more interesting is that because of the specification, so this is the same prompt as previously was done in English. When we do this prompt very specific, like with all these details, then Claude starts to work as an agent. It stops working like a single language model instance. It starts to put like immediate runnings of the program and analyzing them. Funny it is that even though Claude is failing, and even though it is starting to produce not red curve, but the white on the black background, DeepSeek is failing again. Unfortunately, it does not have this hole, which was terrible. Gemini is still keeping the same shape, and finally GPT looks pretty much well, with some problem at the very end. Okay, so this is what we did. We failed. From the very little specific prompt that we had at the very beginning, we went into very sophisticated, precise prompts that are producing curves of different shapes with some fails like Claude and DeepSeek. And I want to express that this does not mean that one of those language models is better or worse. It is also the temperature of the model. It is our luck that we got the curve like this, that is not specific. And sometimes one prompt works better for one model and the other for the other model. Now, when I put this as a YouTube video for my Polish visitors on another channel that I have, one of the visitor commented on it and wrote a prompt that he promised will work in each of the language model the same. What he did was to be more specific and wrote a prompt like this. Write a complete program in C++ that will generate a filled curve shape in the console using ANSI codes to obtain the red color. Use inequality to define interior of the curve. iterate over the x and y coordinates if the point satisfies inequality. So he is more specific about the procedure. Remember that characters in the terminal are usually taller and that they are wide, and so on. Select the loop range so that entire hair fits on the screen. The code should be clean, compile without errors, and so on. And yeah, I know that you want to see the result, but I didn't do this. I leave it for you. So try this prompt by yourself. The visitor on the channel promised that this works the same in each of the language models. Now, a few words about my research in language models. So, because I was always in computational physics, computational modeling, I was really very much interested in writing more like a script or larger text about computational models. I was always dreaming about having a book on LBM, Ising model, Eden, Grayscott, particle and agent modeling, smooth particle hydrodynamics, fluid dynamics, and all the other similar things, or maybe not that similar, but anyway, I was interested in writing about modeling, about to know more models, to implement them. The problem was always that I could even write about them, but to implement each of them is a lot of work. Of course, I can do it, but it is a lot of tedious work, programming work. Then I was thinking, why don't we use LLM to not really write a book, but to write programs for all these models that I was mentioning here. Then I decided to try it, and to think of a new concept for the methodology. And the idea is that we will be using single prompt for each of those models. So for instance, imagine that you have lattice-Boltzmann method and you want to have a code for that. Of course, you can ask, write me a lattice-Boltzmann code. The chat will write you a lattice-Boltzmann code. Then you will specify, no, but I want to have the velocity faster. I want the user to do this and that. This is possible, but with that, it is not easily reproducible. The concept here will be that we have a single complete prompt which is solid. It is a single instruction, and for instance gives you the complete Grayscott implementation, which you can basically run just after the chat is producing it. So then I submitted the book, and hopefully it will be released in July 2025, not in June, in July, by Taylor and Francis, because it was already accepted. So I'm very happy about it, and this is also a reason I'm giving this talk. So 7 months later, after this idea I had, I started working with that. And there are several models that I could talk about. I selected two of them directly from the book. So I was working in the way that I was picking up model by model. Then many of those models are already available in the literature. Then I was thinking, why don't we try to produce something new? A model that is not available in the literature. Then I was thinking, okay, let's try ballistic deposition model. The model is very simple. The idea is that we have a seat in the middle of the screen. Then we shoot from the circle that is around this seat in the middle. So we shoot a ray. If the ray hits the seed, then another particle is attaching to the seed in the middle. Then we select randomly some another angle, and we shoot again into the middle. Then we attach another one, and then step by step our model should build up some kind of a cluster. It is not found in the literature. What I mean is there is no model like this in the literature at all. There are similar models like diffusion limited aggregates and so on, but there is no model like shooting from the circle around the initially middle placed seed. Now, this is, I must I must say that this is a wrong model, because I have some problems with anisotropies here, which I recognized after I seen the result of the model. But yeah, why do I show that? The reason I'm showing that, because this is an example of a model that you cannot find the code in the internet, Because what people usually say is that language models are producing a code by copying from another source, like from the GitHub or other people algorithms. So this is not entirely true. I mean, sometimes, of course, it is copying when you take some standard algorithm and ask about something very simple. But when you get to some specifics and you get to some details, it's very often that it has to basically program it for you. And that was an example. So this is single prompt from the book that I'm talking about, which is producing ballistic model deposition. And the prompt is like that. Write a program in JavaScript HTML, work on the grid with integer values 0, 1, place an embryo in the center of the grid, randomly select a point on a circle with center at the center. Oh, sorry, there is some mistake, but it does not matter that much for the language model when you do small mistakes like this. I mean, everyone understands. You select the point on a circle with center at the center of the layout and radius W. And then, so the circle is placed at the center of the layout and it has a radius W, which is the width of the screen. Trace the radius from the drawn point to the center. So this is what I was talking about. This is the procedure. And when you hit the seed, then you basically fill the cell from which the ray came by hitting that cell. So basically you hit the previous, so maybe I draw it for you. So when there is a seed and you shoot a ray, then when you hit a cell, then you have to draw another one just before this one. Okay, that's the fourth step. Then return to step 3, finish it if the radius of the result cluster reaches W by 2. And so that means when this grows up to the entire screen, so when you put on a new one here, then it will be the end. And let the user choose the properties, additionally optimize your code. So I recognize that this is pretty much a very slow procedure, so it's better to optimize. Then the result was pretty amazing because I got this. And this is a result from the procedure that I was showing you before. It is a code. The code for that was produced by Grok. And interestingly, it is showing the problem that I told you. It is wrong because there is some kind of anisotropy here. So basically this line and this line is showing anisotropic behavior of the model. And this is because of the symmetry of the grid that I was using. And but it's anyway interesting because, as I said, you cannot find it in the literature. So this is like a new model, new result, and it is programmed by Grok just by putting the prompt that I showed you before. Now we can take something more standard. So this is smooth particle hydrodynamics. Here the prompt is pretty much large. It is quite a lot of work to write it down, but it's complete. So it has a basic definition of the model, definition of kernels, definition of the integration procedure. So how do we compute forces and densities, and how do we integrate equations of motion? What are the properties? What is the implementation details about, how do we sweep over neighborhoods and so on? Something about the graphical user interface and the visualization. And all these elements are necessary to really specify the code that you want to achieve. Here the language is Polish because I was using this in the Polish version of the book, and the book is written in English, so there is a prompt in English, which is also complete. So now when we run this, put this into the language model, we will get a program that it's also written in JavaScript and HTML, which not necessarily has to be done like this. It can be, say, C++ or something. But the result is pretty amazing. So this is the result of the model. It is producing SPH simulation live in your web browser. You can open the code, play with that. You can put more particles. And funny thing is that you also get visualization with merchant cubes algorithm here, which I basically asked by one single sentence. So by visualization, use the field of particles and use an algorithm of merchant cubes, because I was not interested in details very much. I just wanted to have the visualization like this. So this gets really fast. I mean, I didn't make the book in 2 evenings. I was really working hard for several months to write each of these models and make it working. But now it is like possible that one is working in this way, at least in the very beginning stage of writing programs and models like this. Okay, so to summarize, the book is about 66 models. It is there are several of them. It's among those that I already told you. There is live, smooth live, soft body, Ising model with phase transitions, and so on. One prompt is for each of the models. It is more than 80,000 words, and the release is in July. So it's small advertisement from me. You are welcome to have it, and I hope you will like it. So I encourage you to have a look. And to summarize, I was working quite a lot with this single prompt methodology. I must say that LLMs are actually writing the software. There are various levels of abstractions of them uh, of those prompts that you are writing. It might be either detailed algorithm or it might be something like just a question about something very specific. And the future, I think, will have agents talking to each other and having some roles that will work on our local machines. We'll have local language models and some kind of personal assistants. So thank you very much. That's all, and you are welcome to see the book in the description of this talk. And yeah, if anyone is here, see you in Prague. I hope to see many people tomorrow listening to the talk. And if you have any comments, please leave here, subscribe to the channel, and yeah, see you. Bye bye.